webinar series that the Southern Plain Transportation Center or SPTC is hosting this year. I am Saeed Ashik Ali, a research assistant professor at the of the civil engineering at the University of Oklahoma. I will be your moderator today. We have Dr. Krishna Srinivasan from Sripath Technology to present on an interesting topic, which is a practical guide on using high wrap mixes. So before we start with our presentation today, webinar today, there are some housekeeping stuff that I want to mention first. This webinar is being recorded, and the webinar, the recording, and the slides will be posted in the SPTC website. So if you need if you have requested a PDH, we are planning to give one PDH for this webinar. So if you have requested PDH, we will be emailing you that PDH certificate later this week. Also about the presentation, we plan to have the presentation first around 45 to 1 hour presentation, and then it will follow with the question answer session. So please, if you have any question in between, please post your question in the chat box. We'll be monitoring the chat box for questions. So with that, I'm going to introduce our speaker today. We have Dr. Krishna Srinivasan. Dr. Krishna Srinivasan is currently the president of Sripath Technologies, providing leadership and strategic guidance across Sripath group of companies. Dr. Srinivasan founded Sripath Technologies in 2006 out of recognition of the growing need across the bitumen and asphalt industry for innovative solutions to common obstacles. Over 25 years of hands-on experience working in the industry, roles across paving and roofing prepared Dr. Srinivasan to navigate the technologies behind bitumen performance improvement. His unique experience with technical applications and commercial product development helped establish Sripath Technologies and its subsidiaries as a global brand. Dr. Srinivasan is a sought-after thought leader, presenter, and lecturer for industry associations, events, and university programs all over the world. Among other credentials, Dr. Srinivasan holds a PhD degree in materials engineering from Rensselaer Polytechnic Institute. With that, I will hand over to Dr. Srinivasan for his presentation.
Thank you, Ashik. Can everybody see my screen?
Yes, we can see.
Wonderful, wonderful. Thank you, Ashik. I will begin with some acknowledgements and some thanks, obviously, to the Southern Plain Transportation Center for hosting this webinar. My thanks to Olivia. Herding cats into a virtual room like this was never easy. She's managed a great feat. Thank you to Professor Ashik and Professor Musharraf. Some of you may know Sripath has been in discussion with the University of Oklahoma to establish a Center of Excellence in Emulsions Research in binders, which we are happy to do. But during the course of the conversation, Professor Musharraf, we briefed him on our product range, and when we came to Relixir, our rejuvenator, he felt that our knowledge base and practical experiences from around the globe would serve well in terms of a kind of a primer on what is RAP, how do you use it, what do you do, etc. So many thanks to the two professors. I should try to advance my slides, which I'm struggling with. So with that, I will talk about what this presentation is all about. What are the benefits of recycling? How do you use RAP? What is RAP? How do you design with it? How do you select rejuvenators, select rejuvenator dosages? What are the different types of rejuvenators out there for consideration? Moving on, what is the impact of high RAP mixes in roadway performance and roadway durability? And then close it out with some remarks on plant operations. Eventually, you can do so many things in a lab. Eventually, they have to be taken to a plant where you make mixes, put them down on the roadway, make it more routine. So I'll spend a couple of moments on that and walk through some of the key items there. So as Professor Ashik mentioned, please hold questions and we can certainly talk about them at the end. Let me begin with the obvious fact statement. As global economies grow, it is widely recognized that GDP growth is a strong, strong function of infrastructure build-out. That means widening existing roadways, putting down new roadways, new accesses, etc. And as a consequence of that, there is increasing amount of RAP, reclaimed asphalt pavement, that's being that we are getting pretty much around the world. This figure, 750 million tons of RAP per year worldwide, is a 2023 number. Comes to us courtesy of NAPA, the National Asphalt Paving Association. And in order to build these roadways, we continue to deplete more and more resources. We need to refine crude oil to make virgin bitumen. We need to mine quarries for more and more aggregate. So there is a way out of this cycle? By the way, that same NAPA organization has also proclaimed that asphalt is the most widely recirculated material, recycled material in the world. Beats steel, beats aluminum, beats glass, beats plastic by a wide, wide margin. And part of that is due to the growing tendency towards using more and more RAP in mixes. So let's begin with, why do you even want to consider reclaimed asphalt pavement or RAP? And the answer lies in two parts. One part is a sustainability argument, and the other part is a cost argument. So let's start with the sustainability argument. This data comes to us courtesy of AFPA, the Australian Flexible Pavement Association, and they were looking at the various elements of making a road, and looking at the carbon impact, the kilogram carbon dioxide equivalent per ton of mix produced. They looked at various factors: the raw materials, bitumen, aggregate, other materials, the transportation, the heating in the plant, the mix production, etc. And they did it for several different cases: 0% RAP, 10, 20, 30, 40, 50, 60, etc. And there, the bottom line is really this top line here. As you systematically increase the amount of RAP, you're able to cut down the kilograms of carbon dioxide per equivalent per ton of mix produced. So it is certainly a winning argument from a sustainability point of view. The second part of the answer is in the economics. This data comes to us courtesy of FHWA. They looked at costs, all the costs that go into putting down 1 lane mile of a roadway. Excuse me. And they broke it down into percentages. And what they found was that over 70% of the total cost of laying down a roadway is in the materials. So anything you can do to put a dent in that cost is going to rapidly find its way towards the bottom line. So today we'll talk about all these various issues. What are the environmental and safety issues? As you can see from the left-hand side, this is really not a static situation. This is more of a dynamic situation where various different factors interact to produce that sustainability nexus that you see in the very center, the Venn intersection points. What are the environmental and safety issues? Or, what is the maximum amount of RAP that you can use to minimize CO2 equivalents? What is the economic viability? What are the cost savings, if any, from using more and more RAP? And what is the most cost-effective percentage of RAP that you can use in your mixes? And finally, obviously, the performance. What is the specification properties? What are the properties of your mix with high RAP? What is the long-term performance? Because you're using high RAP situation, will your roadway age faster? These are all questions that need to be answered. And again, all of this leads to, what is the maximum amount of RAP that I could use in order to meet performance requirements and things like that. And we'll go through all of these various factors. The answer, my early quick answer is, it depends. It depends on a variety of factors, and we'll discuss some of that as we move forward today. So what are some of the key steps towards RAP utilization? This is a very basic slide. It's no different if you're making, using steel to make an automotive. It's no different if you're using glass to make buildings. You start with your raw material. You source it, you prepare it, you test it, you create a mixed design, and then you incorporate that mixed design into a plan. I just want to highlight two things. One, every source of RAP is different. Every mountain of RAP is different. So really, you've got to, there are some techniques to homogenize. There are techniques to produce more consistent feed stream into your plant. We'll talk about that sometime a little bit later today. And the second thing is also very critical. Many people regard RAP as well a waste material, and they treat it as such. When you start throwing in 30, 40, 50% of RAP into a mix, it's even if you're throwing in 20%, it's not a waste material. It's a vital input into your plant operations. So you should treat it as critically as you would any other raw material. Analyze it and make sure that the quality considerations are all met. So this is kind of a blueprint of what I will be talking about in terms of design philosophy. Top half of it is very, very, again, very elementary. You improve the reliable, consistent source of material. You evaluate the consistency. You grade it accurately, the bitumen content, the bitumen grade, etc. You estimate some rejuvenator content. You do some mixed design, and you come up with an answer as to what level of dosage you need, what level of RAP you could use, etc., etc. How does that work in a practical situation? Well, let's look at the bottom half of the chart for that. The first step is you start with your dry RAP and your dry stockpile aggregates. You combine them to meet the gradation and other quality specs that the DOT may have decided. So based on this, you're able to get a certain percentage of RAP. That's the maximum that could be used in that particular situation to meet your gradation specification. The second part of the equation is you look at your binder. So you extract the RAP binder, you mix it with your virgin binder, you mix it with different proportions of rejuvenator, and you look at performance specs. And we'll talk about what performance specs really means. But once you do that, you're able to get a certain RAP content that you may consider for your mix design. The maximum amount that you get from either of these two is your maximum amount that you begin your design analysis with. Sometimes, if you have only one RAP pile, you don't have, coarse, medium, fine, this may be the limiting step. That is, the maximum amount of RAP you can put in is dictated by your dry gradation spec. Sometimes, if your RAP binder is quite aged, or your virgin binder is too soft, too hard, various other factors and parameters that come into play, the bottom may be the rate limiting or the determining step in here. So depending on this, you can choose what rough ranges of RAP you can work with, and then move on to mix design. So let's start with RAP consistency and quality. Left-hand side of the screen, you can see some very standard operations. Those of you who are in plant operations know all of this already. You got a RAP pile that was dug up roads. You screen it for foreign material. You crush it. I use the word crush very loosely. You're not actually breaking stone. You're slitting it. So you're breaking through the aged RAP bitumen or binder, trying to preserve as much of that aggregate as possible. And then you fractionate it. You create different fractions based on particle size. Again, to many of you who operated alongside the side of roads or been in a plant environment, you've seen equipment like this. While you are crushing, you're also simultaneously also fractionating, creating basically a coarse, medium, and fine particle size or more. This is just examples of three. Some plants make as many as 6 different gradations. It really depends on how much RAP you want to use, what's the quality of the RAP, etc., etc. What is the goal from this operation? The goal really is, and this is your standard gradation curve, you got something as inhomogeneous as this. And your goal through this operation, through the crushing, through the fractionation, through the homogenization, is to produce something that's very uniform. Now you've got a very uniform material of high consistency, particle size wise, coming into your plant operations. I want to emphasize homogenize. Homogenization is a very key step. This is one of the things that needs to be emphasized. Wrap really is a variable material. So in extremely small quantities, it's a very variable material. So in order to produce a more consistent feed stream for your plant operations, when you create that wrap pile that you see here, you turn it over 2 or 3 times. You take your earth mover and you turn it over 2 or 3 times to get a more consistent source of material. So how does one go about determining optimal dosage level of rejuvenator? Can be done in 2 different steps, either or. One is at the binder level or one is at the mix level. And right now, let's talk about the binder level. OU is a fine university. I'm sure you have students from Australia, students from Asia, students from Europe. So different parts, graduate students, different parts from different parts of the world, they may bring different experiences. This chart kind of sort of synopsizes all of that in a snapshot. Some parts of the world rely on softening point pen, Europe, China, etc. For them, you would look at either, and this is pen and this is softening point plotted as a function of rejuvenator, and it's really you start with a known pen of a wrap, known pen of your virgin binder, different proportions. You combine rejuvenators. This is what's known as a blending chart. You can do that for pen. You can do that for softening point and determine your range of rejuvenator that you may consider for your mix. Some parts of the world rely on a viscosity spec. Again, a log plot. This is another example of a grading chart. So countries like Australia, countries like India use viscosity, binder viscosity as their guiding spec. And you perform a similar kind of experiment to know what your target viscosity is, and that'll tell you, excuse me, how much rejuvenator you need for that particular wrap situation. We are here in North America, so let me spend a few moments talking about how it is done in USA. As you may know, PG grade consists of a high grade and a low grade. So depending on how you want to go about the situation, you may choose to design or determine your dosage level for rejuvenator based on the high grade or of the low grade. So for example, if your wrap is graded as an 86 minus 10 and you want to get to a 64 minus 22, you may add just enough rejuvenator to take that 86 to a 64, or you may like to take that minus 10 to a minus 22. That's what it means in terms of grading on the high side or grading on the low grade of the binder. Enough studies have shown that if you target the high end, if you determine your dosage of rejuvenator based on high PG, high grade characteristics, you persistently overstate the amount of rejuvenator needed. As a consequence, most DOTs and most practitioners target the low end. They target the low grade and try to determine optimal rejuvenator content for their mix based on low grade. This is how it's done on the binder level. The other way to do it is through BMD, or balanced mix design. And this is done at the mix level. In balanced mix design, all you're doing, again, this is a fancy new concept for something that's been around with us for maybe 50 years. In balanced mix design, you're just looking to optimize 2 competing parameters. How soft is my mix versus how hard is my mix? So how soft is my mix tells you about properties like crack resistance, like fatigue resistance, and low temperature governed properties. How hard is my mix is based on what is its rutting resistance and how well will it resist traffic loads. So for rutting resistance, there are any number. So basically, you'd make your mix with the target rejuvenator and wrap content that the earlier experiment showed you, and you would look for 2 properties. Rutting resistance, measured either by a Hamburg wheel or an APA or a Cooper wheel or a French wheel, sometimes even Cantabro is used. So any number of different techniques, you judge the rutting resistance, the rutting potential of the mix that you've created. And for the toughness part of it, any number of crack resistance. This is really an alphabet soup. You have Texas overlay, you have SCB, semicircular beam bend, you have single edge notch beam bending, you have IFIT, you have DCT, you have ideal CT, any number of different techniques. And indeed, different DOTs around the country have selected different ways in which to characterize fracture toughness. So really think of it as balancing these four properties: potential for cracking, potential for fatigue, potential for rutting, and obviously costs. That too enters into the equation, but perhaps at a subsequent stage. So how does this all work out in real life? Here is a table, just to put this thing in perspective. So this is a 30% RAP, 5% RAS. RAS is recycled asphalt pavement. That is another source of recycled binder into mixes. Many jurisdictions use it. So net effectively, this is a 45% ABR, asphalt binder replacement ratio. That means 45% of the total liquids in that mix is coming from recycled content. So here is an example. You're looking, as I said, you're looking at two competing properties. Here, they have selected Texas overlay as their measure of fracture toughness, and they have selected APA rutting as a measure of their rutting resistance. So this is the control mix properties for the Texas overlay and control mix properties for the APA rutting without rejuvenator. And this is the one with rejuvenator. In this case, 1 kilogram per ton of mix. And you can see this is very satisfactorily meeting both your properties. So this is a practical example of how you would employ balanced mix design in real life. Like I said, replace Texas overlay with ideal CT. You may get different criteria, different numbers. Replace APA rutting with Hamburg wheel rutting. You may get different, but basically the idea is you pick one test from column A, you pick one test from column B, you decide your specifications or whatever specifications the DOT has laid out for you, and you do your experiments to try and arrive at a balanced mix design. So why do you need a rejuvenator? We've spoken so far about how to design with RAP. Now let's talk about and rejuvenator. Why do you really need a rejuvenator? This chart comes to us courtesy of the University of Wisconsin. This data is University of Wisconsin based, and what they were looking at is penetration for different cores selected at different time intervals along several, 3 or 4 different roadways. And you can see a very standard curve of how the penetration changes as a function of life out there on the roadway. Basically, aggregates do not change. So if it was good at the time of design when the road was initially laid out 5 years, 10 years ago, it's probably still good now. In fact, it is definitely still good now. What changes is the binder. The binder in the wrap or the binder on the roadway continues to oxidize. It changes physically, it changes chemically, it becomes more stiff, becomes more brittle, and you need a rejuvenator to restore the physical properties of the binder. There is often a case made that, well, you need to, through SARA analysis, you need to replace the chemical constituency. And frankly, and in fact, some data, not all, some data has borne this out. When you add 1 kilogram per ton of mix, you're not rebalancing anything. From a chemical standpoint, what you're doing is altering the rheological characteristics, the failure characteristics, which could be rutting, which could be cracking, could be fatigue, anything. That's really what you're changing with modern day rejuvenation philosophy. So I'll talk a little bit more about softening versus rejuvenating in the next slide. But I want to acknowledge here the wide variety of materials that have been used and are being used as rejuvenators. And I just want to lay them out there. They all have pros and cons. We'll go through some of them. So these may be petroleum-based oils, paraffinic, naphthenic, aromatic, saturates, etc., proprietary oils. Some people have proprietary petroleum-based rejuvenators. Used cooking oil, McDonald's greases and fats and waxes and things like that have also been tried. Soft grades. Softer bitumen grades is something that has been tried and was in vogue for very many years. Reob, re-refined engine oil bottoms. This is what comes out when you go in for your engine oil change at one of your local automotive places. That used oil is collected, it's turned back into motor oil, and what's left at the bottom is that sludge. Looks like asphalt, is black, is sticky, quite easily flowable, is called reob, re-refined engine oil bottoms. That has also been considered in the past for rejuvenating agent. As I said, they all come with pluses and minuses. And finally, perhaps the most dominant class today is bioblends. Bio-based oils for a variety of reasons: dosage, sustainability, cost, performance, longevity, a whole range of reasons. Proprietary bio-based blends have probably taken center stage as the dominant rejuvenator of choice. I said I'll talk about what is softening and what is recycling. This is your standard waterfall chart. So depending on what your agent, recycling agent or rejuvenating agent does, the first question you ask yourself, does it soften the hard bitumen in my wrap? If the answer is yes, you move to the next step. Does it help adjust my grade? Depending on where you are in the world, it could be a pen grade, it could be a viscosity grade, it could be a PG low grade, whatever. If the answer is yes, does it help with compaction of stiff, high wrap mixes? And finally, this is perhaps one of the most important questions. Does it aid in durability? Does it maintain and provide long-lasting roads? Once you have all of these combinations is when you have an ideal rejuvenator. And we'll talk about what all of this means in actual property terms as we go through the next few slides. This is an, let me say, advertisement alert. A lot of what you're going to see, a lot of the data that you're going to see in the next maybe 4, 5, 6 slides is based on Relixer. These are the characteristics of the material, what it is. It's a blend of bio-based oil, low VOC, low carbon footprint, quite dosage efficient, non-hazardous, etc. And we'll talk about what it does to roadway performance and mix costs, but just wanted to put it out there, just full alert. So what does rejuvenator do in a high wrap mix? This is data from Virginia. It's quite dated, maybe 7, 8 years old. There's a lot of information here, so let me break it down. Mix 1A has 45% recycled bitumen content. 45% of your of the total liquids in that mix is coming from recycled materials. Mix 1A, no rejuvenator. Mix 1B, 45%. 0.28% by weight of rejuvenator. So you make your mix, you extract the binder, and you look for properties. And the reason I always start with this graph is no matter where you are in the world, you can identify with some property or the other. So if you're in a pen world, you can see it takes a 16 pen material, extracted bitumen, and turns it into a 30 to 50 pen material. If you're in a viscosity world, this is what it does to viscosity. If you're in a PG world, like we are in New Zealand or USA or other parts of the world, you're able to take this minus 14 material. The extracted bitumen from mix 1A without the rejuvenator is a minus 14 grade. With the rejuvenator, you're able to get it back to the minus 22, which is one of the most common grades used in the US. So this is what rejuvenation is. This is what rejuvenation does at the binder level. As you move from mix 1, 2, 3, 4, what you're increasing is the ABR, or the recycled bitumen content. So whereas you started at about 45% of the total liquids being recycled content, by the time you reach mix 4, 80% of that total liquids is recycled bitumen. So again, let's look at two cases. Mix 4A, 80% ABR, no rejuvenator. Mix 4B, again, 80% ABR, and about 1%, 0.9% by mix weight of rejuvenator. And you can see what it does to the low temperature grade. It takes it again from a minus 6 back to a minus 22. It takes a virtually zero pen material and restores it back to the 30 to 50 range that most folks in Europe and China use. So, and the viscosity. This is an uncompactable mix. Whereas now, by adding 1% by weight of mix weight of rejuvenator, you're able to get a mix that looks like a stiff PMB, but nevertheless still very compactable. This is what it does at the binder level. What does rejuvenation do at the mix level? For that, let's turn to Illinois Tollway. Sandy Lender is in the room. So yeah, this was written about in Asphalt Pro some years back. Please check out that magazine, some excellent articles on a variety of topics, but this was written now up there. They were looking, their base grade is a PG 58 minus 28, and they wanted a 40% ABR mix. Consisted of some RAS, consisted of some RAP, and they wanted to design a mix with their standard base binder. They also wanted to design the mix with one grade softer. Remember, we talked about softer grades. They also wanted to design that, see its impact on performance, on the roadway, etc. Over 2,000 tons of material was produced with these materials and put down in base course, in shoulder course, and in wear layer course. They use DCT as their measure of fracture toughness and Hamburg wheel as a measure of their rutting resistance. Remember BMD, you're looking for one fracture toughness property, you're looking at one rutting property, trying to balance the softness of the mix versus the hardness of the mix. What you can see is that the rejuvenated mix with the standard 58 minus 28 binder easily met the spec properties. In fact, they were happy enough with that. They wanted us to put down for a stretch of roadway with a slightly higher rejuvenator content, with a view towards improving this number in future upcoming rounds of specification to increase basically the cracking resistance and the fatigue resistance of their roadways. And they were able to do that, get a higher level of DCT or fracture toughness while maintaining an acceptable level of rutting. This is again the balance of trade-off of properties in a BMD. What you can also see is that the one grade softer not only proved to be the more expensive of the mixes, it could not adequately do the job. Indeed, there are cases as the amount of wrap increases or the age of the binder in the wrap increases, softer grades become less and less effective. There are also other problems with softer grades, and we'll talk about some of them, but that's one of the things. I just want to highlight a couple of other points on this chart just to catch your attention. If you look at the virgin binder added, this is the amount of virgin binder added to the mix. As you increase your rejuvenator content, you're systematically able to take out more and more of your binder. And that's because your rejuvenator is now forcing more and more of your wrap binder to behave like normal binder and deliver on these level of spec properties. The other thing I'll highlight is as you increase your binder, it's able to improve delta TC. Delta TC is a measure of aging resistance. We'll get to it a little bit later, what it is and what it does and what different examples there may be. But in general, good effective rejuvenator should at least maintain the aging properties of the native or the virgin bitumen added. That is one of the goals. That is, it should take the wrap bitumen and be able to produce a effective bitumen that shows good aging properties. This is data that comes to us from Australia, and I'll highlight a couple of things in here. That certainly there's a lot of data here in terms of the properties they measured, the pen, the softening point. As I mentioned, Australia is a viscosity-driven country. They looked at complex viscosity. Here's some JNR data. But first, let me highlight this. The binder used is M1000. M1000 is an air oxidized, a very stiff air oxidized binder. Seems to work fine in Australia. Many DOTs, in fact, if not all in the US, have banned air oxidized binders here in the US. However, the reason I bring this up is because one of the things people ask me as I tour, customers ask me is, so does your rejuvenation and high wrap technology work only for normal binders, or does it work for PMB binders? Does it work for SMA binders? Does it work for air oxidized binders? The answer to all of this is yes. It depends on the mix design. The second thing I want to highlight is the CT index. In this chart, the CT index is a measure of fracture toughness, measure of crack resistance, potential to resist cold weather cracking or fatigue stresses. Even though this mix has 40% wrap with 3% rejuvenator, it's able to produce, even though the rutting properties are roughly similar, it's able to produce a vastly more damage tolerant material, vastly more crack resistant material as measured by the ideal CT. I mentioned this also comes to us from courtesy of Australia. The reason I highlight this is, again, just a couple of points, a lot of data here, but I'll highlight a couple of points here in terms of the control mix is 0% wrap, and the high wrap mix is 40% mix wrap with 3%, 3-odd% of rejuvenator, 4.9, almost 5% by weight of rejuvenator. Couple of points I'll highlight. The JNR numbers look good. Complex viscosity numbers, which is how they grade their binders, look good. But I want to focus on this. This is 4-point beam bending fatigue results. Strain tolerance, the threshold for 1 million cycles. What is the effective strain? And you can see that in well-designed mixes, you're able to mirror the properties of mixes with well-designed high wrap mixes. You're able to mirror the properties of mixes made with no wrap at all. Here you can see that the fatigue strain tolerance in 4-point beam bending is roughly equivalent for the two mixes. This one is with the high wrap, sorry. This one is with the high wrap. This one is with no wrap at all. Moving on, I mentioned SMA. I'll just highlight in brief. This is a trial run by UK National Highways. This was with SMA type binder. It is being written about in a German, technical details are being written about in a German conference upcoming in September. I'm happy to share those results with you once they are published. We do have a lot of data that shows very good properties of the high wrap. This case, it was 50% wrap mix on a SMA binder case. Let's move on to slightly higher levels. This is a 60% wrap mix, and they use two binders, AC20 and AC30. Those of us who are old enough remember AC grading of binders before we moved to PG grading. So again, two cases in each, 0% wrap and 60% wrap, and they measured a variety of parameters. Permanent deformation in air is measures to rutting. Penetration tells you a little bit about the binder characteristics, the water sensitivity, etc. I want to focus on this. Remember, we spoke about sustainability, and this was the first time it's published in the Irish Annual Conference. This was the first time they were able to systematically measure and document that as you increase the wrap percentage with the rejuvenation, you're able to get a total lower greenhouse gas potential, greenhouse gas warming potential, kilogram carbon dioxide equivalent per ton of mix. You're able to see a systematic decrease as you increase the amount of wrap. So that's the reason why I wanted to highlight this. So, so far you've looked at 25% wrap, 30, 40, 50, 60. This is a case of 100% wrap mix in a New York City mix, drum mix. So imagine, if you will, there is no binder in this. So there's just wrap and rejuvenator. So if you take a bunch of wrap in your palm and close your fist, open it back again, and literally just put a couple of drops of rejuvenator. This one was done at 0.55, about 11 pounds per ton of mix. So it's literally a couple of drops in your fist. When you open up your fist, if the material falls through, your rejuvenator is not effective. Clearly, at least the first test is it should produce a sticky mass that can be laid down and compacted. We certainly achieved that and more. So what did we do? This is a plant manufactured, drum plant manufactured product measured in the lab. New York City uses Marshall stability and Marshall flow, at least at the time. So we clearly met that. But why I wanted to highlight this is 1 year later, we went back and took field course. and measured SCB, semicircular beam bending, as a measure of crack resistance or fracture resistance, and Hamburg wheel tracking as a measure of rutting resistance. And you can see that 1 year later, they were still meeting the original specification. Let me move to another topic. This is something we always emphasize, which is aging characteristics, durability characteristics. So here is a series of experiments. Again, a very busy chart, so I will break it down, take my time to break it down for you. Made a mix with no wrap, 5.5% virgin bitumen, made the mix, oven aging 4 hours, loose mix oven aging 4 hours, 8 hours, and 16 hours. So you make your mix, you oven age it, and this follows the protocol that NCAT, some of you may have read the report from a couple of years ago. They correlated this kind of aging to field aging. So roughly this corresponds to anywhere from 7 to 10 years of actual roadway experience, this kind of an aging regimen. So you make your mix, you compact it, and measure ideal CT. Clearly, as you age the material, you expect the ideal CT to fall, and that's what you see. We took this data, just put it here, and compared it to two mixes, both with 30% wrap, both with 4% virgin bitumen. In one case, you add 5% of petrochemical oil as your rejuvenator, and in the other case, you added 3% of a bio-based rejuvenator as your rejuvenator. Again, same procedure. Make your mix, oven age it for 4, 8, and 16 hours, take it out, compact it, and measure ideal CT. What you can see is that the petrochemical oil is able to show a high level of initial ideal CT index. But as a function of aging, it's vastly inferior to that of the mix made with no wrap. That's not the case for the mix made with the bio-based rejuvenator. Not only is the high initial value high, but the terminal value, the long-term age value, is very similar to this. And this is true for both the 30% wrap case and the 50% wrap case. And what this chart tells you is that it is possible. It is possible to design with high wrap, design good mixes. If you have the right mix design, if you have the right rejuvenator, if you have the right dosage, you can make mix designs with high wrap that show similar performance both initially as well as long-term aging, after long-term aging, that compare very favorably to mixes made with no wrap at all. This is a key chart. This and the subsequent key 2 or 3 charts are key charts that are needed by DOT officials as they look at the propensity of your material, of any high wrap mix, to last out there in the field. So that was what the previous chart was, what it did at the mix level. What does aging of high wrap mixes look at the bitumen level? So again, very similar experiment. You make 2 mixes. In the first mix, it's just virgin bitumen and aggregate. In the second case, it's bitumen, aggregate, rejuvenator, and wrap. And so you make these mixes. Again, this is a 46% ABR mix. It's quite a common threshold. Anywhere from 40 to 50 is quite a common threshold. Few people do 60, rarely above that. So just to drop it out there. So you make these 2 mixes, one with no wrap and the other with wrap plus rejuvenator. You make the mix, you extract the bitumen, and then subject it to 20-hour, 40-hour, and 60-hour PAV aging. And you look at the stiffness S and the M value, the compliance M value, and that's where it's plotted here. You can see that the 2 curves for the high wrap case as well as the virgin case with no wrap at all, after aging, the curves just lie one on top of the other, showing you that not only is it able to provide satisfactory initial level properties, but this rejuvenator is able to match the aging characteristics. There's virtually no difference between the no wrap case and the 45% ABR case. I mentioned soft bitumen. Indeed, this was one of the lead competitors to rejuvenators, probably 2014, 15, 16, maybe even up to 2018, 19. There's a number of reasons why. As I said, there's the dosage efficiency issue, one, two. For some certain high wrap mixes, depending on the wrap content, depending on the age of the binder in the wrap, et cetera, softer bitumens don't work by and large. And certainly, not just the dosage efficiency, but the ease of use and the safety issues and the quality issues. The world has gravitated towards bio-based rejuvenators. But here is one important chart why. This is not, again, an isolated case. We have similar data from pretty much every continent out there, from Asia, from Australia, UK, and certainly more examples of this in the US. So what did we do here? We took a bitumen from a refinery and measured the delta TC. As you know, you subject it to 2x PAV. You take your bitumen, you subject it to 40-hour PAV aging, and you look at the difference between the S and the M value, the stiffness and the compliance value, to compute what's known as a delta factor. And a lower negative number is better, just generally, so that you can keep your eye on that. We took that same bitumen and we rejuvenated it with 5% by weight of a bio-based rejuvenator, and did the same thing, subjected it to our 2x PAV, 40-hour PAV aging, and looked at the delta TC. Very similar value to the base binder. We got a 1 grade softer material from the same refinery and did the same procedure, 40-hour PAV aging, and looked at delta TC. And this chart, and there are other charts like this that DOTs are increasingly becoming familiar with. This chart tells you that the way in which the refinery or the terminal got to the softer binder matters to the aging characteristics. So it depends on what it is that they added or did not add, or what it is that they did. It may or may not. This is not to say that all soft bitumens are bad. However, there have been abundant number of cases where softer bitumen have not provided the same degree of aging resistance as have other materials like bio-based rejuvenators. So this is another kind of a highlight chart as to, if you wonder why it is that bio-based rejuvenators have taken center stage, certainly dosage efficiency, certainly the safety aspects of it, certainly the ease of use aspects of it, certainly the cost aspects, and in the feasibility indeed, but also the long-term aging characteristics are another driving factor in something like this. I mentioned earlier on petrochemical-based rejuvenators, again, useful, instructive to know why it is that they've fallen out of favor. Firstly is a flat-out case of dosage efficiency. You need roughly 2 times as much to achieve the same grade of a petrochemical versus a bio-based. Could it be 70, 80%? It's possible, but roughly 2 times as much is a good approximation. That's one. It has cost implications. Certainly dealing with some of these chemicals and oils certainly has their own implications. But here is 2 different ways to look at aging behavior of binders that have been, and indeed mixes, high wrap mixes that have been rejuvenated with different types of rejuvenators. Here, 2 different petro oils, 5%, and in another case, 5% of a bio-based rejuvenator. You can see that the delta TC behavior of the bio-rejuvenator is vastly superior to that of the petrochemical. Not only is this true at the binder level, delta TC, it's also true at the ideal CT or mix level. The fracture toughness, the crack resistance, if you will, of the material is vastly inferior to that of bio-based rejuvenators. So we've gone through all of this. We've looked at how to classify a wrap, how to make it consistent, how to get it ready for plant operations. How do you design with them different mix levels, the property implications, what kinds of rejuvenators are out there, how do you select among them, and how do you get to dosage, etc. You've done all of this. Now you're looking to bring it into the plant. And the first point I will say is what I harked back to earlier, which is based on your mix design, you may come up with a certain level of wrap that you thought you wanted to use based on your dry gradation or your binder characteristics or your mix design, BMD mix design, you may have come to certain level that you thought was optimum for you. Some of you, and this is may not be true in your particular state, but increasingly environmental factors, sustainability factors are becoming a choice for DOTs, particularly in Europe, Australia, etc. So you get brownie points for having more sustainable solutions. That may influence your decision. But at the end of it, all of this comes down to a plant. A plant manager is going to look at it and he's going to say, well, what are your requirements? And he's going to go through his design calculations and he may tell you, you have made a mixed design for 60%. The best my plant is going to do is 40. And there are a number of reasons for that. It depends. I said this earlier. I'll say this again. If you fractionate your wrap into coarse, medium, and fine, you will be able to, in general, add more wrap to your mixes than if you just had two or just had one gradation. That's one factor. Minimizing the dust in the wrap, getting a consistent gradation, that may influence how much of wrap your plant that you can use in your plant. Wrap preheating, this is critical. Imagine, if you will, you want to make a 40% wrap mix. That means 400 kilograms for every 1,000 kilograms coming in is wrap. If it comes in cold, it throws your heat balance completely out of whack. If it comes in wet, then that moisture has to be driven off. That heat has to be supplied to really provide the latent heat of vaporization. That severely compromises the ability of the plant. Indeed, if a plant is running, let's say 300 tons per hour, 40% wrap for several days in a row, you have a rain squall, your wrap pile is not tarped over, it's not sloped, your plant manager is going to reduce both, perhaps one or even both. He's going to reduce the amount of wrap. If he was running 40, 45, he may end up running 30, 35 for the next 2 or 3 days while the wrap dries out. If he was running 350 tons an hour, with 40% wrap, he may just be able to run 250 tons per hour of wet wrap. So a lot of factors influence how much wrap ends up being in a consistent mix. And some of this is clearly on the plant manager, on the ops manager, and how they maintain their situation. And finally, analyzing the wrap is very, very critical. The plant manager needs to be assured that if he thinks he's putting in 40% wrap at 4.3% virgin binder content and let's say a grade of -10, -6, -15 something, he needs to know that that's happening hour after hour after hour, because he has a very limited ability to test and react. He's already made several thousand tons before the test results, even from the fastest QC lab in the plant, have shown up. So he has limited ability to react. That analysis, that homogenization of the wrap and the analysis of that wrap has to be good. Draw samples from multiple spots in that pile. To the quality control engineers in the room, draw multiple samples and analyze it very carefully for bitumen content, analyze it for bitumen grade, other factors, and really provide your plant with a very clean bill of health so that he can run the operation at a fast enough pace. I'll start again, staying on with the plant manager. You may think you produce the best mix design. The students in the room may think you produce the best mix design. You may have thought that you've really selected the best material, etc., etc., etc. But here, right-hand side, health, safety, and environmental issues. These are some of the things that the plant manager thinks about. Does it have a high enough flash point? Are you going to set fire to my plant? Is it safe to handle? Do I need special PPE? Does it produce toxic byproducts? Is it stable at mixed temperatures, stable at use temperatures, stable at storage temperatures? Is the viscosity a strong function of whether it's cold out there, 40 degrees, or whether it's hot out there, 70 degrees, 80 degrees, 90 degrees? These are all factors that he would consider, or she, your plant manager, would consider. But generally speaking, around the world, there are very many different ways in which you can incorporate your rejuvenator into your operations. If all you're doing is making, let's say, 40% wrap mixes for 6 weeks, 7 weeks in a row, and this is not uncommon in many, many parts of Asia. They just add the rejuvenator to the bitumen storage tank and just keep feeding it and keep running their plants, typically pug mills or batch operations. Um, if your plant, for example, and increasingly this degree of sophistication is coming about throughout the world, if your plant produces, let's say, 40% wrap mix for 3 hours and then 30% SMA mix for 2 hours, 30% wrap SMA mix for 2 hours, and then 60% wrap mix for commercial jobs for the next 6 hours, you need the ability to adjust that tap of rejuvenator as you're able to adjust that incoming virgin bitumen line. You should also be independently capable of adjusting the rejuvenator flow rate. In those cases, the best option would be to have a co-injection. You inject through a separate line. So again, it's very simple. All of this is very readily available commercially. Equipment is very readily available commercially. You should be able to inject through a non-return valve the rejuvenator into your bitumen feed stream as it is feeding your drum or as it is feeding your pug mill. Indeed, both of those cases. And this is also one of the most prominent ways in which rejuvenators are introduced into plant operations. And finally, if you've got a very high wrap content, if you've got 70, 80, 100% wrap, there's not enough amount of virgin bitumen to be injecting all this stuff. In those cases, and this is a very tricky operation, I should caution everybody in the room, 100% wrap, 90% wrap is not an easy thing. But there are customers who do that. They do feed the rejuvenator directly on the wrap conveyor belt as it is feeding into the drum, as it is feeding into the pug mill. A couple of different plants around the world that run 80, 90, 100% wrap. And indeed, this is how they feed rejuvenator into the system. So we've spoken about a lot of things. I want to highlight, certainly when you look at reclaimed asphalt pavement, the environmentalist looks at the sustainability aspect. Again, I didn't mention this, but one of the reasons why bio-based rejuvenators have caught fire in several different parts of the world is they generally bio-based rejuvenators, depending on the kind of rejuvenator, depending on their composition, they provide a net negative number for the GWP. So if your control mix has a certain, with low wrap, let's say, and no rejuvenator, has a certain carbon footprint, you're able to lower it by using selective bio-based rejuvenators. So you have environmental reasons why you may consider wrap. And again, you may have performance reasons, you may have availability reasons, but this is also a major reason why people look at high wrap mixes. Here we're looking at two mixes, a control mix with 15% wrap and no rejuvenator. You tot up all the costs. It has got, obviously 5.5% virgin binder. You tot up all the costs and you create a cost index. Let's call that 1. Next, you look at a high wrap mix, 40% wrap mix with about 0.1% by weight of rejuvenator and 3.8% of virgin binder. You tot up all the costs. Typically, well-designed high wrap mixes save the contractor anywhere from 5 to 15%, depending on his operations, depending on his cost input of various raw materials. Again, proven fact across many different continents. And the reason for that is simple. By now, you should be clear to you guys. The use of an effective rejuvenator forces more and more of that wrap binder to behave like virgin binder, depending on how much you've added, dosage you've added, and how you've designed your mix. You can typically save costs. And this is one of the dominant reasons, guys. I won't lie to you. This is one of the dominant reasons why high wrap mixes have really, really taken off in the past, let's say 10, 15 years. One has been simply the availability of bitumen. Many parts of the world are net importers of bitumen, and with that comes with higher costs and higher regulations and things like that. That may be a driver. Some people just look at the ever increasing price of bitumen And so that is their driver. But in general, this is a fact, and this is a big motivator for forces, because clearly, once you start moving into high RAP situation, and there are quite a few ops managers in the room here, they know this. There is some capital expenditure that is to be made in order to be able to run. If you're running 10-15% RAP, yeah, it's possible to run with existing equipment. Once you start getting to 35, 40, 45, 50% RAP, you need certain engineering interventions. You need some cost of capital in order to be able to do it, and it should pay back. And this is, in fact, one of the not only the a very quick payback, typically of the order of anywhere from 6 to 18 months, depending on what it is that you have to do to modify your plant. But the payback is very rapid, and the savings are real. So with that, let me, I guess my time is running up. I hope I hit all the points that you guys were looking for. A kind of a quick summary, nothing that I haven't said before. You know, you can make high RAP mixes with with good properties that equal virgin bitumen mixes. Control of the RAP material is important. Rejuvenation is key. Not all rejuvenators are creative equal, and certainly you can help have a handle on costs. There's much more information on our website, you know, data, test cases, blogs on how to do this, etc. So please check us out on the website. And with that, thank you. Let me return control to Ashik.
Yeah, thank you. Thank you, Dr. Srinivasan. Very good presentation and very informative. So we got a couple of questions on the chat box. So I will go over those, and it will be very, okay, we have like around 12, 13 minutes left for this presentation, for this webinar. So let's try to answer those questions as briefly as we can. The first question is, could you share your thoughts or philosophy on crash versus fractionate when processing wrap and maintaining its integrity, or protecting the wrap so the binder is not broken loose from the rock?
Ah, this is actually a very good question. There are people who design equipment. So if you went to Wordgun, if you went to any number of different companies that make equipment, they take pains not to break the rock. First step, when you get that pile and you're trying to break it up into different particle sizes, you don't want to crush the rock because it's got a right particle size gradation based on your previous road. It worked for your previous road. You want to maintain as much of that as possible. So that's one. So it's more of a shredding operation than it is of a crushing operation. That's one. Two, it is inevitable that you're going to generate fines in this process. And the fines are usually 99% of the case are going to be fine bitumen. It's actually a very valuable source. So some amount of that fines, introducing it into your mix is really a good idea, because they don't contribute to the gradation in the final mix, but they do contribute valuable binder, which you are trying to utilize. As you know, as many of you in the room will know, on a coarse half inch, you may get anywhere from 1 to 3% binder. On some of the fines, you may get anywhere from 5 to 7% binder. If that fine is RAS based, not RAP based, you may get 25, 30% binder. So those fines are important. At the same time, you don't want to crush rock. So this is a fine-tuned operation. Any one of the guys, Benningon, Aman, any one of them can help you design equipment. They've done this before. They will do it again. Design equipment for suitable fractionation and crushing.
Thank you very much. Our next question is on homogenization, homogenization as well. Based on your experience, what percentage of asphalt mix producers practice homogenization of wrap piles? Could you talk about the size of the wrap pile with the homogenization process?
Size of a wrap pile is typically, let's say, at least 10, 12 feet high, typically, again. I didn't have a chance to talk about it. Good wrap management practices. You always want to have it on a slope bed to allow natural drainage of water. You want to tarp it. You want to protect it from moisture as much as possible. But homogenization is very, very key, very, very critical. And 100% of the wrap users, of the high wrap users, high wrap mix producers, practice homogenization. Without that, you can't make a consistent material. So you turn that pile over 3, 4, 5, 6 times till you get a good, consistent material. It's not a very difficult operation. It's something that people do routinely. So it's something that is practiced, must be practiced at the plant level.
Sure. Thank you very much. Another question is about the dust that is produced during wrap production. So if you fractionate wrap, it will likely produce fines that may not be incorporated in asphalt mixes because of gradation requirements. What would one do with those wrap fines?
Typically, as I said, fines are that are associated with dust. Inevitably, you're going to crush some rock. That has to be removed. There are techniques to remove that. That is not of great use. In fact, many producers, if not all, introduce dust from their bag house operations back into the mix to manage out the fines part of their dry mix design. The fines that are high or very high in asphalt content typically become entrained with particularly the smaller sizes. If you have coarse medium fine, they will tend to associate themselves with the fines and get used up in the operation. They are a very valuable, rich source of bitumen binder that you can revitalize using an effective rejuvenator.
Okay, thank you. Okay, yeah, another question is, could you discuss about how much binders from wrap get blended effectively with the mix, particularly for highly aged and high wrap mixes?
Again, a very good question. There is any number of researchers who are looking at effective binder content. The term that's used for this is effective binder content. If I have, if I do a burn and I find out that my wrap has 5% of binder, organic material, shall we say, how much of that is ending up in my mix as useful, effective binder? There have been many studies. There continue to be many more studies. My answer is going to be somewhat distorted. It's more, since this is a practical guide to rejuvenation, my answer is going to be distorted by that. Let me say this. There will always be some amount of black rock. Black rock is material that's essentially so aged that it behaves like a rock. It may look, it may look like a rock, but it's black, but there's hardly any effective binder that you can use out of that. There will always be some amount of black rock in your wrap pile. However, the way to take care of it, or the way to design around this dilemma, is to do a balanced mix design. Because a balanced mix design does not care what your theoretical calculations are about effective available binder. It is reacting, it is producing properties, in this case ideal CT or rutting or IFIT or DCT or Texas overlay. It's producing a number based on the actual conditions that are present in that sample. So again, this is another vote of confidence for BMD. This is what's being done pretty much throughout around the world. First step, people estimate. They come to us for rough guidance on dosage selection. We give them some ideas. They make mixes, they test mixes. Different parts of the world use different criteria to measure the efficacy of the mixes. Some parts of the world use Marshall. Some parts use fatigue type testing. Some parts use cracking type testing. But whatever be the test that their DOT feels comfortable with, you should always do some BMD type work, because that's actually what you're not driving on asphalt. You're driving on mix. So your properties must be at that mix level. And BMD is, again, time and again proven to be one of the more effective ones pretty much around the world.
Sure. Thank you. The next question is about the difference between petro-based rejuvenator and bio-based rejuvenator. So, what chemical or molecular properties of bio-rejuvenator contribute to better performance of mixes than the petro-based rejuvenator?
Now you're getting into the proprietary end of things. Let me just say this: in bio-based rejuvenators, and there are quite a few excellent companies that make excellent bio-based rejuvenators. We're one among them. In bio-based rejuvenators, again, there is a unique blend of properties that allow for a number of different things to happen. One is their dosage efficiency. They're far more dosage efficient than petrochemical-based rejuvenators. They're far more aging resistant, if you will.
Okay.
far more easier to use. Some petrochemical rejuvenators must come in hot and be used hot. Some obviously are, can be used under normal ambient conditions, but all bio-based rejuvenators are used just at ambient conditions. So that's another fact. Again, it's very, very safe to use, very easy to use. So because of a number of different factors, bio-based rejuvenators have clearly gained, the dominant pole position. Today, hardly anybody, people certainly use all kinds of rejuvenators, but serious production pretty much around the world, not just the USA, not just Canada, has come to rely on bio-based rejuvenators.
Thank you. We have a few more questions, so only a few like 2-3 minutes time probably. So let's try to get those. What about the stability after adding rejuvenator? And would you discuss about the long-term field effect, property degradation, if the rejuvenator is not stable?
I don't know what you mean by not stable. In a well-designed rejuvenator, let me start by saying this. In a well-designed rejuvenator, you clearly, have a high flash point. You want it compatible with bitumens. If you're a worldwide seller like us, you want it compatible with a wide range of bitumens and wide range of wrap available worldwide. So these are factors that rejuvenator manufacturers hopefully test before they put a product out there. So stability has typically not been a concern. I don't know of cases. I certainly am not aware. However, the questioner may be aware. If he or she is, they should share some experiences. But in general, once it's mixed into the bitumen, there's typically not a problem. Long-term performance, as you know, the field of rejuvenation, the best that I can tell you what Relixir has been put down so far is 10 years. So while it is true that, you don't know the 20 or 30-year effect of this thing, we don't know the 20 or 30-year effect of modern day bitumens, which are nowhere near the fine grade Venezuelan crude we used to get even as recently as 10, 12 years ago. So increasingly, the incoming bitumen, the incoming binder is a blend of various different sources from various different parts of the world. Could be Canadian, being mixed with material from Tarragona, Spain. And so there is a number of incongruities in the bitumen business itself today. So we think that the performance is adequate to provide long-lasting life. Many DOTs certainly agree. So that there is that. By the way, I also want to interject. If there are more questions, please be in touch with Ashik. He knows our email. He knows our phone numbers. We're happy to take as many or as few questions that you have if time should not permit today.
We have 4 more questions. So let's try to solve it
Okay.
Let's try to get on this. The next question is, how will the rejuvenator interact with the SARA fraction? Can we expect the same proportions as in virgin binders after rejuvenation? Some studies have reported an increase in oxidized functional groups in rejuvenated binders. Could this pose a long-term durability concern?
Yeah, this is again a question that I think is somewhat academic in nature, and here's why. As I mentioned before, you're adding 1 kilogram of rejuvenator to a ton of mix. It is hardly possible that it will alter the SARA fractions to the point where I guess it's even meaningful or noticeable. Having said that, I will also say this: what really matters is performance. And I think that's where more DOTs are gravitating towards, which is what is the performance of my mix? How is it behaving on a roadway? Does it last a long time? Yes, there have been studies that have shown high, oxidative species in aged material. Despite that, well-designed rejuvenators continue to perform, continue to show good results. So I guess that I realize this is not a serious answer for an academic. However, it's what's happening out there in real life today.
Sure, yeah. Thank you. The next question is, what is the significance of Relixir? Corn oil, tall oil, sunflower oil. soybean oil, whatever it is. So as it has different combinations of oils.
It is a proprietary blend. Let's just say that and leave it and move to the next question.
Okay, sure. How many? So this is a very, I think, tough question as well. How many times can we recycle a wrap with rejuvenator?
Very good question. We have some data. I didn't have a chance to go through this. Clearly, if you take the same mix and recycle with the same amount of rejuvenator again and again and again, clearly there is some drop off in performance. But that's not what's happening again out there, guys. What's happening is they're getting wrap from the field. They're analyzing it. They're putting together a mixed design based on that wrap, and then they're with rejuvenator, and they're putting down the roadway. 5 years from now, 10 years from now, they'll get a wrap. They'll do the same procedure. The amount of rejuvenator, the amount of wrap, the amount of various factors can change. This is why mixed design is so important. You work with what's in front of your face. You don't work with, geez, has this material been recycled 4 times over? You don't do that. What you do is, I got this mix from the side of the roadway. I need to put it back into the roadway. How much of this can I put in? And what levels of rejuvenator? What is the impact on rutting? What's the impact on fatigue? What's the impact on cracking? Those are the kinds of questions that folks are answering. Yes, there is a fall off if you use the same wrap again and again and again and the same amount of rejuvenator. There is a fall off in performance, but I submit to you that your starting material is not quite the same each time. So if you optimize based on the starting material each time, you will find quite happy results.
This is the last question we have. Riob normally has a more negative delta TC. How would this problem can be solved?
You can't solve the problem with Riob. This is why Riob is banned in several states in the Northeast, and some people still continue to use it. Okay, there's nothing. But in general, let's take a moment and look at Riob. Cheap material. There's no doubt about it. Dirt cheap material, but the aging performance is not there. The dosage efficiency is not there. It has to be transported hot, used hot. So your tank needs to be heated. So there are a number of issues with Riob. It's not that they haven't been considered. They were considered and then eliminated from consideration because of property deficiencies, costs, infrastructure related issues, and hazmat related issues as well. So number of reasons why Riobs have fallen out of favor. Again, not just in the US, also I would also say Europe, Riobs are not being used for rejuvenation or softening applications.
Thank you. With that, I think that's the end of our question and answer session. Thank you very much. Please give a virtual round of applause for our our great speaker, Dr. Krishna Srinivasan. It was very informative and very we'll get to learn a lot about RAP and rejuvenation and whatnot. So thank you very much for your time. With that, we also want to let you know that with University of Oklahoma, SPTC is having some, we are joining to collaborate on some collaborative project, and we are trying to establish a new dimension to our OU asphalt research group here. Thank you very much to SPTC, Dr. Srinivasan, and also other team members. Thank you for your support. Dr. Zaman, do you want to say anything here?
No, I think it's a great, wonderful job, Krishna. I think we have a lot more to learn. So I'm going to actually attend those RAP 101 multiple times. Thank you very much.
Thank you. Thank you to the university. Thank you to the Southern Plain Transportation Center. Really appreciation to Olivia as well. Thank you for the opportunity. As I said before, if you have questions, Ashik knows how to track us. So please reach out to him. He will be able to route any questions that we haven't been able to answer. Deepak and I are more than happy to answer. Thank you again. Thank you so much.
Absolutely. Thanks to all.
Thank you very much. Thank you everyone for joining this webinar. So just If you have requested PDFs, we will send out those PDFs around the end of this week. And if you have any topic that you are interested to hear, interested, and we can host that topic, please let us know. We are going to send a survey. Please respond to that survey, and we will have another webinar pretty soon, and we will let you know. Olivia, our SPTC manager, will reach out to you about those information. Thank you very much, everyone. Have a
Thank
good day.
you.
Thank
Thank
you.
you.
Bye.